Painting electric motors is generally not recommended due to its potential negative impacts on heat dissipation and motor performance. According to IEE Standard 112.2004, Section 11.2.2.1, paint or other similar coatings on the motor are not recommended, as it can impede heat dissipation. An Emerson Electric white paper titled The Impact of Paint on Electric Motors concludes that painting motors can reduce heat dissipation by up to 15%, leading to increased operating temperatures. Rockwell Automation, in their application note The Effects of Paint on Electric Motors, warns that painting motors can result in overheating, reduced motor efficiency, and premature failure. Baldor Electric, in their bulletin Painting Electric Motors, states that painting motors can reduce heat dissipation and shorten motor life, and therefore it is not recommended to paint motors. The potential consequences of painting a motor include reduced heat dissipation. Paint creates a barrier that inhibits the transfer of heat away from the motor. This can lead to increased operating temperatures, reducing the motor's efficiency and lifespan. Many motor manufacturers, including Baldor, state in their warranties that painting the motor may void the warranty. Overheated motors pose a fire hazard and can damage equipment and infrastructure. Motors that are painted may require more frequent maintenance or replacement due to premature failure. It is advisable to leave the motor in its original finish to ensure optimal heat dissipation and maintain the manufacturer's warranty. Total enclosed fan-cooled or TEF motors are designed to dissipate heat through their external surfaces. Painting these motors can reduce their ability to transfer heat effectively. The paint acts as an insulator, preventing heat from escaping the motor's housing. This can lead to a rise in the motor's internal temperature, which can damage its components and shorten its lifespan. The motor's efficiency decreases as its temperature rises, requiring more energy to perform the same amount of work. Firstly, the increase in operating temperature can degrade the insulation of the motor windings, leading to short circuits and motor failure. Secondly, the paint can also block the ventilation openings of the motor, further reducing its ability to cool itself. Thirdly, some paints contain solvents that can damage the motor's seals and bearings. Fourthly, the warranty may be voided. Many motor manufacturers specify in their warranties that painting the motor voids the warranty. Fifthly, painting the motor can make it difficult to inspect for damage or wear. Sixthly, the added weight of the paint can also put stress on the motor's bearings and other components. Seventhly, the paint can also trap moisture and dirt, leading to corrosion and other problems. Eighthly, the paint can also interfere with the motor's grounding system, increasing the risk of electric shock. Ninthly, the paint can also make it difficult to remove the motor for repair or replacement. Tenthly, the paint can also reduce the resale value of the motor. It is essential to consider the potential consequences of painting an electric motor before making a decision. If heat dissipation is a concern, it is best to leave the motor in its original finish. If painting is necessary, use a paint specifically designed for electric motors that will not impede heat transfer. The motor's nameplate provides essential information, including the motor's horsepower, voltage, amperage, and operating temperature. This information is critical for ensuring that the motor is operated within its design limits and that it is properly protected from overloads and other hazards. The motor's service factor indicates the amount of overload the motor can handle for a short period. It is crucial not to exceed the motor's service factor, as this can damage the motor. The motor's insulation class indicates the maximum temperature the motor's windings can withstand. Operating the motor above its insulation class temperature can damage the windings and shorten the motor's lifespan. The motor's enclosure type indicates the level of protection the motor provides against environmental factors such as dust, water, and chemicals. Choosing the correct enclosure type is essential for ensuring that the motor is protected from the environment in which it is installed. Electric motors generate heat as a byproduct of their operation due to electrical resistance in the windings, friction in the bearings, and magnetic losses in the core. This heat must be dissipated to prevent the motor from overheating, which can lead to insulation breakdown, reduced efficiency, and premature failure. The primary method of heat dissipation in TEF motors is through convection, where the motor's fan circulates air over the external surfaces, transferring heat away from the motor. Radiation also plays a role, where heat is emitted from the motor's surfaces as infrared radiation. Conduction can also occur, where heat is transferred through the motor's mounting base to the surrounding structure. The rate of heat dissipation depends on several factors, including the motor's surface area, the temperature difference between the motor and the surrounding air, and the airflow rate. Painting the motor can reduce its ability to dissipate heat effectively by adding a layer of insulation that inhibits heat transfer. The paint's color and texture can also affect its ability to radiate heat. Darker colors absorb more heat, while smoother surfaces radiate heat more efficiently. Proper ventilation around the motor is crucial for ensuring adequate heat dissipation. Obstructions to airflow, such as enclosures or nearby equipment, can reduce the motor's ability to cool itself. Regular cleaning of the motor's surfaces can also help to remove dust and dirt that can impede heat transfer. Motor manufacturers typically provide guidelines on painting their motors, including recommendations on the type of paint to use and the number of coats to apply. Following these guidelines is essential for maintaining the motor's performance and warranty. Some manufacturers offer specialized paints designed for electric motors that provide good heat transfer properties. These paints typically contain additives that enhance their thermal conductivity and emissivity. When selecting a paint for an electric motor, it is crucial to consider its thermal properties, durability, and resistance to chemicals and other environmental factors. The paint should also be compatible with the motor's existing finish to prevent adhesion problems. Applying the paint correctly is also essential for ensuring that it does not impede heat transfer. The paint should be applied in thin, even coats to avoid creating a thick layer of insulation. The motor's ventilation opening should be masked off to prevent paint from entering the motor. The motor should be allowed to dry completely before being put back into service. Regular inspections of the motor's operating temperature can help to identify potential problems with heat dissipation. If the motor is running hotter than usual, it may indicate that the paint is impeding heat transfer or that there is a problem with the motor's ventilation. In such cases, it may be necessary to remove the paint or improve the motor's ventilation to prevent overheating. Electric motors are critical components in many industrial and commercial applications, and their proper operation is essential for maintaining productivity and efficiency. Understanding the factors that affect motor performance, including heat dissipation, is crucial for ensuring that motors operate reliably and efficiently. By following best practices for motor maintenance and painting, users can extend the lifespan of their motors and avoid costly downtime. The National Electrical Code, or NEC, provides guidelines for the installation and operation of electric motors. These guidelines cover topics such as motor protection, wiring, and grounding. Adhering to the NEC is essential for ensuring the safe and reliable operation of electric motors. The NEC requires that motors be protected from overloads and short circuits using fuses or circuit breakers. The size of the fuse or circuit breaker should be based on the motor's full load amperage and service factor. The NEC also requires that motors be properly grounded to prevent electric shock hazards. The grounding conductor should be sized according to the NEC tables. The NEC also provides guidelines for the installation of motor control equipment such as starters, contactors, and variable frequency drives, or VFDs. These guidelines cover topics such as wiring, grounding, and enclosure requirements. The NEC also addresses the use of motors in hazardous locations, such as areas where flammable gases or dust may be present. Motors used in hazardous locations must be specially designed and certified for use in those areas. Proper maintenance of electric motors is essential for ensuring their safe and reliable operation. Regular maintenance should include inspections for signs of wear and tear, cleaning of the motor's surfaces, and lubrication of the motor's bearings. Motors should also be tested periodically to ensure that they are operating within their design limits. Overheating can significantly reduce the lifespan of electric motors. Therefore, it is essential to take steps to prevent motors from overheating. This includes ensuring that motors are properly ventilated, that they are not overloaded, and that they are protected from environmental factors such as dust and moisture. Variable frequency drives are commonly used to control the speed of electric motors. VFD can improve motor efficiency, reduce energy consumption, and extend motor lifespan. However, VFD can also generate harmonics, which can cause problems with other electrical equipment. It is essential to install VFD properly and to use harmonic filters to mitigate the effects of harmonics. Electric motors are available in a wide range of sizes and types to suit different applications. The selection of the appropriate motor for a given application depends on factors such as the load requirements, the operating environment, and the available power supply. Consulting with a qualified motor specialist can help to ensure that the correct motor is selected for a particular application. Energy efficiency is an increasingly important consideration in the selection and operation of electric motors. Energy-efficient motors can save significant amounts of energy and reduce operating costs. Many utilities offer rebates and incentives for the purchase of energy-efficient motors. The National Electrical Manufacturers Association, or NEMA, has developed standards for energy-efficient motors. NEMA premium motors are the most energy-efficient motors available. The Department of Energy, or DOE, has also established energy efficiency standards for electric motors. These standards require that all new motors meet certain minimum energy efficiency levels. Replacing old, inefficient motors with new, energy-efficient motors can be a cost-effective way to reduce energy consumption and improve overall energy efficiency. When replacing a motor, it is essential to consider the motor's efficiency, its horsepower, its voltage, and its enclosure type. It is also essential to ensure that the replacement motor is compatible with the existing equipment. Electric motors are complex devices that require careful consideration to ensure their safe and reliable operation. By following best practices for motor selection, installation, maintenance, and painting, users can extend the lifespan of their motors, reduce operating costs, and improve overall system performance. The horsepower rating of the motor indicates the amount of mechanical power the motor can produce. The voltage rating of the motor indicates the voltage at which the motor is designed to operate. The amperage rating of the motor indicates the amount of current the motor draws when operating at full load. The insulation class of the motor indicates the maximum temperature the motor's windings can withstand. The service factor of the motor indicates the amount of overload the motor can handle for a short period. The enclosure type of the motor indicates the level of protection the motor provides against environmental factors. The efficiency of the motor indicates the percentage of electrical energy that is converted into mechanical energy. The power factor of the motor indicates the relationship between the voltage and current in the motor. A lower power factor results in higher energy losses. The synchronous speed of the motor is the speed at which the motor's magnetic field rotates. The slip speed of the motor is the difference between the synchronous speed and the actual speed of the motor. The starting torque of the motor is the amount of torque the motor can produce when starting. The breakdown torque of the motor is the maximum amount of torque the motor can produce before stalling. The locked rotor torque of the motor is the amount of torque the motor can produce when the rotor is locked. The moment of inertia of the motor is a measure of the motor's resistance to changes in speed. The bearing life of the motor is the expected lifespan of the motor's bearings. The lubrication requirements of the motor indicate the type and amount of lubricant that should be used to lubricate the motor's bearings. The vibration levels of the motor indicate the amount of vibration the motor produces during operation. Excessive vibration can damage the motor and other equipment. The noise levels of the motor indicate the amount of noise the motor produces during operation. Excessive noise can be a nuisance and can damage hearing. The environmental conditions in which the motor is operated can affect its performance and lifespan. Extreme temperatures, humidity, and exposure to chemicals can damage the motor. The altitude at which the motor is operated can affect its performance. Motors operated at high altitudes may need to be deaerated. The maintenance schedule for the motor should be followed to ensure its safe and reliable operation. Regular maintenance can help to prevent motor failures and extend motor lifespan. Troubleshooting procedures for the motor should be followed to diagnose and repair any problems that may occur. Proper troubleshooting can help to identify the cause of motor failures and prevent them from recurring. Electric motors are essential components in many industrial and commercial applications. Understanding the principles of motor operation and maintenance is essential for ensuring their safe and reliable performance.